Hello everybody, today I'm going to tell you a little bit about naming molecules. So naming in chemistry we call nomenclature. And it works better for me to have my paper sideways for taking notes today um, because we're going to look at kind of a decision tree. First of all, I'm going to tell you the nomenclature system for the not acids, and then we'll do another page which will be for the acids. So not acids, and we haven't gone into what an acid is, but this is usually going to be there's no hydrogen in the not acids. And we'll talk a little bit more about that later. But okay, so the first thing we have to figure out if we're going to name a compound is it ionic or covalent? And in order to answer that question, we need to look at our periodic table. For something to be ionic, that means we have a metal, and a metal will be an element on the left-hand side of the periodic table, and a nonmetal. So the nonmetal will be something on the right-hand side. Then that will be ionic. So if we have metal plus a nonmetal, then that will be ionic. And then covalent will be a nonmetal and a nonmetal. And that's how we tell the difference. So covalent, you'll have two elements from the right-hand side of the periodic table only. Okay, now if it's ionic, then we have a system of naming. But the name is going to depend on us answering a couple more questions yet. So first of all, is it binary or is it ternary? And binary is just a fancy word for two elements. Two different elements means a binary compound. Ternary means more than two elements. Okay, now if it's binary, then we still need to answer one more question before we can determine the name. Do we know the metal's charge or not? Okay, so when do we know a metal's charge? We know a metal's charge if it's in the first column, it's plus 1. If it's in the second column, it's plus 2. And those are the main two rules. There are a few others that are known, and that's silver's always plus 1, zinc's always plus 2, aluminum's always plus 3. You see that's kind of a staircase, plus 1, plus 2, plus 3. And those are the ones that will require you to know. So first column, plus 1, second column, plus 2, plus 1, plus 2, plus 3. So if we know the metal charge, so we'll say yes, we know the metal charge, then the name will be equal to the metal name and then the non-metal name but ending in "-ide". So we need this "-ide" suffix. So for example, one that probably most of you already know, if we have NaCl. So NaCl, the Na is a metal, the Cl is a nonmetal. So we know that's an ionic compound because it's a metal and a nonmetal. We also know that it's binary because we have just two elements, sodium and chlorine. So two elements. We also know the metal charge because sodium is in the first column, so we know it's +1. So then the name is just the metal name. The metal is sodium. And then the nonmetal name, the nonmetal is chlorine, but instead of sodium chlorine, we call it sodium chloride. So we replace the end of the element name with the suffix "ide". All right, so that's one system of naming for ionic binary with a known metal charge. What if it's ionic binary, but we don't know the metal charge? So if it's no, we don't know the metal charge, then we need to indicate that somehow. So the name will be the metal name. So far it's just the same. But then a Roman numeral in parentheses, and this will be the charge. So we have to figure out the charge somehow. And then blank "ide" again, where in the blank we put the nonmetal name, or at least the beginning of it. So for example, if we had FeCl3, so the metal is iron, but iron can have different charges, and that's true for most of the 8 transition elements. They can have a variety of charges, or sometimes they're called oxidation states. So we can write iron, but then we need to specify which charge this particular molecule is, and then it will be chloride. So how do we figure out the charge? Well, we know that chlorine is typically a -1. This whole column is -1. So if the chlorine's -1, and I have 3 of them, but overall it's neutral, it must be that the iron is +3. So I put a Roman numeral 3 in there. So iron 3 chloride. All right, so that's the system of naming for ionic, binary, and then with a known metal charge or an unknown metal charge. Then let's look at ternary, so more than 2 elements. So if we have more than 2 elements, again, we need to know, is it a known metal charge or not? So again, we have to answer that question, and if it's a yes or if it's a no, we're going to have 2 different names. So if it's a yes, then the name will be just the metal name. Like before, no more Roman numeral, and then plus the anion name. So the anion will be the name for the whole polyatomic ion that is the thing that has the negative charge. So what am I talking about? So for example, if I had Na2SO4, sodium, I know the charge is +1, so this would be called sodium. And then the SO4, this is one of those polyatomic ions that we're memorizing. Notice they're both nonmetals, the sulfur and the oxygen, but there's more than one of them. That's why the ternary name is a little different. For the ternary name, you need to know those memorized polyatomic ion names. So SO4 we know is sulfate. So the name is sodium sulfate. Okay, and then as you might expect, if we don't know the metal name, then the name would be the metal name, and then plus the charge in Roman numerals, and then plus the anion name. So for example, if I had FeSO4, then Fe is iron. Need to put the charge in there, sulfate. But what is the charge? Well, in order to figure out the charge, I need to remember that SO4 is a sulfate ion, and sulfate is SO4 2-, but overall it's neutral, so in this case the iron must be 2+, so that's iron 2 sulfate. Alright, I think that's enough for this video. You'll have a practice question, and then we'll look at how we name the covalent non-acids.